Hi everyone, and welcome to our webinar today. Thanks for joining us. We have 17 different universities and colleges tuning in. Doug, can you introduce our speaker?
I'm happy to. Thank you. Stu Walesh is an independent consultant, teacher, and author providing leadership, management, and education training services. Prior to beginning his consultancy, he worked in the academic, government, and business sector, serving as a professor, a dean, project engineer and manager, marketer, and litigation consultant. Stu, that's a lot of lists, but it represents a summary, a breadth of experience, and I'm sure you've got a lot of wisdom to share. He's authored 6 books and many engineering publications. His most recent textbooks are Introduction to Creativity and Innovation for Engineers and Engineering Your Future, the Professional Practice of Engineering. Stu has given several hundred presentations throughout the U.S. and internationally. We're fortunate to have him. Over the past 1.5 decades, he's been active as a practitioner in the effort to reform the education and early experience of civil engineers. Thank you, Stu, for joining us today.
Thank you, Doug, for the introduction. And welcome, everybody, to this webinar with a somewhat unorthodox title to it, in that we're talking about our brains. And that's why I begin my statement of the purpose of today's webinar with the word explore, as in let's explore the idea that if engineering faculty acquire more knowledge of recently discovered brain basics, they can be even better educators. Elena, I need some help advancing the slide. All right. Brain knowledge has exploded in recent times. According to physician Richard Restak, we've learned more about the brain in the past decade than we did in the previous 200 years. And this new knowledge has practical implications for most professions and vocations. The value is not confined to medicine. In my research, I encountered neuropsychologist Paul Nussbaum, and he said this: there is perhaps no greater untapped resource in the universe than the human brain. The human brain is no longer the domain of medicine. My point, it's our domain, if we so choose. So the question may arise, why would I, an engineer, study the brain? The short answer is by accident. Let me give you a medium-sized answer. Back in about 2008, on a whim, I signed up for a one-day graphite pencil drawing class in my community. This would have nothing to do with engineering education or practice, which, as Doug indicated, are my professional interests. I enjoyed that day and decided to continue taking drawing classes. These are some of my early graphite drawings, and I gradually moved into colored pencil and acrylic. But again, this was a diversion, no connection to engineering. Then I discovered this book, Betty Edwards' book, Drawing on the Right Side of the Brain. Contains many useful drawing tips. I completed many of the exercises. But then I realized that the title has 2 meanings. Sure, it's a drawing book, but Betty Edwards is also saying that K through 12 education emphasizes left brains too much at the expense of developing and using the right brain capabilities. She urges us to draw on, to pull on, to engage the right side of the brain. As she very succinctly says, half brain is better than none. A whole brain would be much better. That thought engaged me and took me back to engineering. So over the past about 6 years, I've studied and conversed and wrote and spoke about the brain within the context of engineering. And then very recently, Pearson and I published this textbook. While finishing it, and in fact working with a great copy editor, my mind began to wander, and I started to ask myself basically this question: what about brain basics and teaching and learning? And that leads me to today's topic, which I'd like to break into two pieces. Let's spend about the first third or so of our time together laying a foundation of brain basics, not at the neurosurgeon level, very fundamental, very basic. And then let's use that to suggest ways, to consider ways we can help students. The human brain, well, Nussbaum says, greatest untapped resource in the universe. I like to think of it as maybe the most magnificent entity in the universe. It's about the size of a head of cauliflower, weighs about between 2 and 4 pounds, or maybe roughly 2% of our weight. Contains 100 billion cells or neurons, each of which interacts with roughly 10,000 other neurons. And although this brain comprises only 2% of our weight, it consumes over 20% of the blood pumped by our hearts. As our hearts pump, at least 20% of the blood at a rate of about 15 gallons per hour goes right to the brain. It carries glucose, nutrients, and oxygen, and it carries away carbon dioxide and other waste products. That brain accepts and acts on information from 6 senses: vision, of course, hearing, smell, taste, touch, and proprioception, which first time I heard it, I didn't know what that was. That basically means our brain's ability to sense our body position, movement, and posture to keep us in balance. We also know from neuroscience that vision trumps all other senses. It takes up, as one neuroscientist says, half of our brain's resources. John Medina summarized some research findings in support of this idea. He mentions one research study in which, when information was presented only orally, 72 hours later, the recipients remembered only 10% of what was presented. But when information was presented orally and with visuals, 72 hours later, the participants remembered 65%. Recognizing this role of vision, educator James Zoll says we should, quote, make extensive use of images to help people learn. Other educators say the same thing. I suspect that most of us know this intuitively. Yet, we and our students sometimes do counterproductive things regarding our use of the sense of vision. We'll revisit that later. Let's say we could take off the top of our skull and look in. We'd find that our brain has neat, symmetrical left and right halves or hemispheres. They're connected by white communication fibers, about 100 million of them. By the way, the left and right hemispheres are not reddish. They're more pink-gray. This neat symmetry has an important exception. It is asymmetrical with respect to these kind of capabilities. Now, what we're doing here is trying to summarize on one simple table a very complicated situation. But take the first pair. Cognitive scientists tell us that our brain, the left side, when it's functioning, is functioning in terms of words, text, whereas the right hemisphere is nonverbal. Or go near the bottom, the second from the bottom. The left side of the brain is very logical when it functions. Step 1, step 2, step 3, induction, deduction. Whereas the right side of the brain is intuitive. These highly different capabilities of the two sides are very relevant if we want to make wise use of our brains. The brain's asymmetry enhances some of our memories. Assume you're recalling an afternoon at the beach, maybe last summer, maybe 10 years ago, with your significant other. You were there on an August. It was Saturday. You were there from about 2 to 4:30 p.m. The air temperature was in the low 80s, and there was a light breeze off the sea. That part of your or my memory is courtesy of the left hemisphere. As you continue to recall that afternoon, you also feel the sand on your feet, taste the salt air, and experience the pleasure of his or her touch. That part of the memory is provided by your right hemisphere. Total recollection of that wonderful afternoon requires your whole brain. Looking ahead, does this suggest that our and our students' most significant future accomplishments and events are likely to be those resulting from engaging the left and the right hemispheres? The whole brain, like Betty Edwards says? Hardwiring of the brain is a metaphor suggesting that the brain is like computer hardware. Its physical parts are fixed, like the Dell computer I'm using right now when it came off the assembly line. While that view goes back a couple hundred years, now we know the brain is neuroplastic. Neuro is for neuron, and plastic is for changeable, malleable, modifiable. Norman Doidge, in his book, The Brain That Changes Itself, says the damaged brain can often reorganize itself so that when one part fails, another can often substitute. And he gives example after example after example of the neuroplastic brain. In other words, the brain doesn't work like this, a fixed mechanism. Now we know it's more like a muscle. It's neuroplastic. It can grow new neurons, and it can establish new connections among neurons. Another way of viewing our brain is to recognize that we have a conscious mind and a subconscious mind. A conscious mind means, well, we're thinking and we know it. Right now, I'm thinking, what am I going to say next? And right now, maybe you're wondering what I'm going to say next, and or understanding what I'm saying right now. That's our conscious mind. But our subconscious mind is operating below the surface. It's thinking. It's thinking 24/7. And you or I have absolutely no idea what it's thinking right now. Maxwell Maltz, an MD, put it this way. You can give problem solving and idea getting tasks to your subconscious mind. Send it off on a search while you do other things, even while you sleep. And have it return with useful material you didn't know you knew and might never have obtained through conscious thought or worry. Doesn't that sound intriguing? Consider the relative cognitive activity of the conscious and subconscious minds. Someone said the conscious mind is the smallest player in the operations of our brain. The biggest player is the subconscious mind, which resides below the surface. The conscious mind is the tip of the iceberg. The subconscious mind is the bulk of the iceberg. Someone described it as that giant and mysterious factory that runs below. Interesting thing about a conscious mind, unfortunately, not only does it do the least amount of our thinking, but it can only consciously think one thought at a time. Speaking of consciously thinking, What about when we are not consciously thinking but still operating? When we are in a habits mode? How much of what we think and say and do is habitual, is happening largely without our thinking? I've found many responses to that question, but they all are 50% or more. Some as high as 95% of what we think, say, and do is habitual. We are on automatic pilot. Have you ever driven your 2-ton vehicle 75 miles an hour on the interstate highway for a mile and realized you don't even remember doing it? That's your subconscious mind at work. We use our subconscious mind for new situations. While our subconscious mind, our habits, good or bad, take care of routine activities. Thankfully, we have a subconscious mind. Otherwise, we wouldn't be able to deal with all the realities of life. But here's my point. If so much of what we do is habitual, then it would seem that improving any aspect of our life, or our students improving any aspect of their life, means we ought to examine our habits, select the least productive ones, and try and change them. And I'll offer some thoughts on that later. Are we dissatisfied with work, studying, family relationship, community? Maybe our habits are the fault. There's a beautiful little book that I read many years ago called The Greatest Salesman in the World. No, it's not just about sales, but it's about mindset. It's written by Og Mandino. And here's what he says about the power of habits. In truth, the only difference between those who have failed and those who have succeeded lies in the difference in their habits. Good habits are the key to all success. I will form good habits and become their slave. Well, maybe a little over the top, but there's a tremendous amount of wisdom there if we believe that more than half of what we think, say, and do is habitual. So how do habits work? I'll tell you what neuroscience says. We experience a cue. We may not recognize it consciously, but our subconscious mind picks up on a cue. This causes us to go into a routine without thinking, typically. And we get a result, which usually in the short run is nice. Here's an example. Later this afternoon, you usually do it about 3:30 your time. You feel thirsty. You don't really think about it. You automatically get up from your desk and you walk down the hall and you purchase a soft drink and tastes good. You do this day after day after day. It's a habit. You don't think much about it. If you were to think at the end of the week what you did this week, that is, drink 5 cans of sugar-laden soft drink, you might say, well, maybe that's not a good idea. Or how about one of your students? At the end of the school day, at the end of classes, they walk into the dorm room or their apartment, and without thinking, they turn on the TV so they can relax, and other activities follow, and eventually, very, very late, they do their homework. They did all this without really thinking. But at the end of the week, at the end of the month, at the end of the semester, they realize they're getting low grades, and they're frustrated, not to mention their parents too. Maybe they would say, I need to change habits. Select some of bad habits, like I think this one that has to do something with my studying, and replace it with something more positive. We'll revisit that too. Our brain has a built-in, largely unneeded today, negativity bias. Our ancestors lived in a harsh environment. A few years ago, my wife and I, our daughter, and our son-in-law spent 2 weeks in Tanzania. And on 3 of those days, we sort of lived with hunter-gatherers who live today out in the open, day-by-day existence, like they did 10,000 years ago. Our ancestors would wake up each morning and have to make a decision. Should we stay inside our cave or shelter and be safe? Or should we go outside to hunt and gather and be at great risk? They had to choose between starvation and predation. If they went out, they could easily end up being lunch as opposed to eating lunch. Our ancestors learned to be very cautious. Your students would appreciate this example of negativity bias. You ask them to give a presentation in class. Because of negativity bias, they and many of us will see this one person who doesn't want to be there and certainly isn't interested in even hearing what we have to say, even though almost everybody else in the room is reasonably interested in the presentation and hopes to get something out of it. This negativity bias has the power to prevent our students from trying new things, from being creative and innovative and entrepreneurial, and could lead them to tremendous regrets later on. So here, we don't need this negativity bias now, not to the extent we did, but here's the problem. Our brains are like Velcro for bad experiences. In my 30s, I was sitting on a platform in front of 300 engineers and academics, along with several other about to be introduced speakers. I was on the edge of the platform. And as the moderator was introducing the speakers, I managed to fall off the platform with my chair. And I can still to this day remember the laughing, and I can still to this day remember the expressions of concern. Well, I did what anybody would do. I put my chair back up on the platform, climbed up on the platform, gave a talk. Not a very good one. That's my point, though. Our brains lock in bad experiences, but good experiences slide off like they're on Teflon. That's the way our brains work. That stops us from doing so many interesting things. You're invited to speak at a national conference, but you declined because of an earlier disaster. You've always wanted to play the guitar, but you remember being forced to go to music lessons when you were 8 years old. You always wanted to start a part-time business, but your lemonade stand failed when you were a kid. If we let the negativity bias control things, stop us from taking chances, we're going to end up with great regrets. Jim Rohn, the motivational speaker, said this: we must all suffer from one of two pains, the pain of discipline or the pain of regret. Discipline weighs ounces when you're on your deathbed, but regret weighs tons. If our students succumb to our brains no longer needed negativity bias, they're going to miss out on many rewarding professional and personal experiences. They're going to unnecessarily frustrate any entrepreneurial inclinations they have. All right, that's first part of my presentation, an introduction to the brain. And I hope you realize this is not at a neurosurgeon level. This is at a level of basics. But I have yet to show you what good it is. Elena, maybe we have some questions that you could share with me and I could respond to.
Sure, I'll turn it over to Doug to answer some questions, but I want to let our participants know that you can ask questions using the question box that you can see on your control panel. If you just want to type those in, then Doug will read those off to Stu.
All right.
Doug, I'll turn it over to you.
Thanks very much, Elena. Yeah, there are a couple of questions, and some are, one is if I can ask something that I recently experienced. I had a student after a presentation, Stu, that came forward after the talk and said, I want to learn more about how I can change my habits. And so it's classic engineering. You know, the brain is just another resource. It's a processor. How do you maximize that resource to do something useful? And so this is how the student's disposition. And of course, he was a student, so he was pursuing one resource, the traditional education path. Here's my long-winded question. What outside of traditional education exercises that neuroplastic nature of the brain?
What outside of traditional education?
What's outside?
I would think that for many of us, we may have more inclinations to stretch our brain outside of the classroom than we might have in the classroom. That is, outside of formal education rather than inside of formal education. And the reason I say that is, and I'm sure some of you have exceptions, so much of formal education is focused on, okay, your brain is fixed. We want to see you perform at a level consistent with the status of your brain. We want to see if you can regurgitate what we talked about over the last 2 weeks, if you can get the right answers to these questions. Whereas, and I'll talk a little bit about this later, if the students were told that they're not there to perform, to demonstrate sort of their fixed cognitive capabilities, they're there instead to make mistakes, to take chances, to engage in a learning process in which they're actually going to change their brains. They're not there to perform at a level consistent with their brains. They're there to try to reform, R-E-F-O-R-M, their brains. Well, perhaps that's too long an answer, but that's a thought, Doug.
That's helpful. Here's a question that's coming in, and you and others have talked about our future and its dependency on using both left and right hemispheres of our brain. The commenter says, I've read A Whole New Mind by Dan Pink, which has some popular commentary on that. But actually, when I try to think about or talk to people on the topic of the brain, they tune out. I don't know what to do. Could you just comment on maybe there's two questions here. It's not really in the form of a question, but could you talk about how people react to some of the message that you have, and then maybe there's some advice for this particular individual?
I'm going to answer the question with an actual story that will illustrate what I think is happening here. Several years ago, I was contacted by a client, a firm I had worked for several years earlier. And they said, we'd like you to come back, Stu, and make a presentation, or a couple presentations at our annual meeting. Give us some topics. One of the topics I gave them was kind of like we're talking about today, Neuroscience 101, helping you all work smarter. So I get these 6 top executives on the phone. And I say, what do you think about that idea? They said, we're unanimous. We want nothing to do with it. I said, why not? They said, look, Stu, we're in the trenches 10 hours a day. We don't have time for ivory tower, idealistic, theoretical, academic stuff like that. So many times I have had that reaction. I mention brain and people turn off. I think, Doug, at one time you and I were talking, and one of us came up with the expression, people think of the brain as something kind of squiggly. They don't want anything to do with it. Or they think of it as being so complicated that they couldn't possibly take the time to learn about it and then use what they learn. But these same engineers can understand all the workings of a complicated manufacturing process at Ford Motor, or of a complicated water supply, water treatment, water distribution, water treatment again, water disposal process in a community. Those are very complicated systems. They can do all that, but they can't get interested in taking the time to learn brain basics. This completely illogical to me, and maybe it's my fault that I'm not doing a good enough job at communicating. But I'm not going to quit. That's one of the reasons why I'm here today. I have found the academic community to be somewhat more open than the practice community.
Thank you, and I do agree that we with maybe that comment before, we've got to treat it like a resource and figure out how to maximize its use and do something useful. We've got, Elena mentioned that we had 17 universities. Here's a question from the University of Dayton, and it's, which part of the brain is excited by new experiences? And maybe you could just talk to that. We've got one more question after that too.
Excited by new experiences? It's probably a little part of the brain called the amygdala down in the middle of the brain, which is where our emotions come from, whether they're positive emotions or negative emotions. Also, of course, the frontal cortex, the massive part of the front of our brain, is where we very carefully and in great detail interpret what's coming our way and decide if it's mundane or if it's possibly special. But we have to remember that almost anything we're doing, any thought we have, any behavior, anything we say, is really the result of functions occurring in many parts of our brain at the same time. We're not highly compartmentalized. We can get back to the slides.
One more question, and if you've got time for it, it's what techniques can we use to help change habits to overcome specifically the negativity bias? That question comes from Worcester Polytechnic Institute.
Great segue to something I'm going to talk about. So could we defer that? I'm going to talk about how to change habits.
Perfect. We'll defer that and back to your comments. Thank you.
Thank you, Doug, and thank you to the participants for the questions. Elena, perhaps you could restart the slides. It seems that when we go to the camera, I lose control over the slides.
Hi, Stu, you should have access. Try changing them now.
No, it doesn't want to work. I'm going to try the thing we talked about when we started. I'm going to put it, oh, well, now it's disappeared. Oh, there we go. We're back. Show my screen. We'll try that again. There we go. Well, a logical question when I sometimes get to this point in the presentation is, well, you've told us about the brain, but so what? So let's get more practical. And we can easily do that. And I can share some ideas with you. How do we use brain basics to help students? Let's start with something real easy. Let's take multitasking to task. Perhaps you, but certainly your students, are great at multitasking. They text, they email, they Google, they tweet, they blog. They did all that in the last 2 minutes. They are certainly busy. But are they effective and efficient? What does neuroscience tell us? Well, we'll go back to John Medina. He's one of many that have observed what happens when people participate in multitasking. And he says you're going to suffer 2 consequences when you multitask. One is it's going to take you longer to do something. Let's say you have a task. It's a 30-minute task. Maybe you were asked or volunteered to write minutes or a summary for yesterday's department meeting. And you know if you put your mind to it, you can knock that out in 30 minutes. But if while you're doing that, you decide to check your email and tweet and get somebody on the phone and then jump back to this, the absolute amount of time you're going to spend on that task is going to be 60 minutes. Well, you say, 30 minutes, what does it matter? But when we do that over and over and over again, it adds up to a lot of time. The other consequence, according to Medina, is we're 50% more likely to make errors. My engineering practitioner friends, when you attend their meetings, inevitably two topics will come up within their organization. One is more efficient use of time, because if they can make more efficient use of time, they can increase their profitability. The other item that will come up is concern with making errors or omissions, because that leads to liability. And if they can reduce liability, they can reduce cost and make more profits. Even though they're concerned about those two things, it's hard to get them to think about how more knowledge about their brain would help them. A newspaper reporter, Peter Bregman, stopped multitasking for 1 week. He noticed many benefits and he wrote about it in an article. He noticed more things. He made progress. He reduced stress. He lost patience with some things. He gained patience with others. But surely there were some downsides. No downsides. I tell you, if I were back in the classroom, at some point in my course, I'd ask the students to conduct the same experiment for just 1 day. Have the discipline for 1 day to not multitask. And when you come to class the next time, each of you share one thought about that experiment. Let's turn to counseling struggling students. This is where we can use neuroplasticity. I mentioned James Zoll earlier. He has a book titled The Art of Changing the Brain. And when asked, why did you call it that? He said, well, I define teaching and learning as the teacher and student working together to physically change the student's brain. Physically change the student's brain. How about every one of us have had a student come to us and say, I don't have the brain for this. I remember when I started graduate school, I was asked to go over to the mechanics department, take a course in probability and statistics, and when I came back to our apartment, I told my wife, I said, I don't think I have the brains for this. Let's converse with that student and say, look, your brain is neuroplastic. We're here to help you build that brain by adding new neurons and making new connections. Don't think of your brain as something fixed. Think of it as something you're working on by thinking, making mistakes, trying new things. Then say, you and I are working together to physically change the brain. And whatever your or my well-intentioned advice was in the past, because of this basic knowledge of neuroplasticity, maybe the student will say this, I don't have the brains for this yet. That's a big yet. What we're doing is casting the student's dilemma as continuing the natural development of that 3-pound marvel between their ears. To me, this is more scientifically based, more empowering, and more promising than saying, work harder. Now let's get to habits. This was brought up during the questioning period. There it was related to negativity thinking, but this applies to anything. If so much of what we think, say, and do is habitual, then we ought to be open to changing habits. We should encourage students to inventory their habits if they can recognize them. That's not easy. Find the most destructive ones, pick one of them, and try to change it. So let's say a student says, I have the bad habit of putting off doing homework until late at night. And I want to replace it with a habit of doing my homework earlier. How can I do that? Well, one answer would be just do it. But that's a habit. It's ingrained in their brain. It's the result of connections between many neurons. You can't just think yourself out of it. You got to change it. You got to reconnect the neurons. So you say, well, what's the cue? And after spending some time with the student, the two of you concluded that the cue is when that student walks into the dorm room or apartment at the end of the class day and flips on that TV. So you say, well, you'd recognize the cue. When you walk into the room, that cue, you need to start a new routine. And the new routine is you're going to sit down and you're going to do your homework. You're going to do one of your homework assignments that's going to be due the next day or the day after that. Okay. So the student, the first day, does that. And the result is, got the homework done. And he or she liked the result. Isn't that great? Unfortunately, the student's very far from replacing that bad habit with a new habit because he or she must persist many, many cycles. Now, the literature will give you all sorts of estimates, on the number of cycles. I don't give that much credence. But the kind of habit you and I are talking about right here, just off the top of my head, I would say it's probably going to take a month to change that habit. But eventually, the student's subconscious mind will learn a new habit, and the payoff will be what? Reduced stress, greater academic performance. Now, somebody asked a question about the negativity bias. The cue there is given an opportunity. And apparently the routine is to immediately think of some past experience similar to the opportunity that turned out to be a disaster. Well, instead of that, why not have a habit of saying, when I get that cue of an opportunity, why don't I think about my goals? Might this opportunity match with one of my goals? That might be the way to learn a new habit about the old habit of succumbing to negativity bias. All of this takes great discipline. Many cycles are required, but the payoff is terrific. That habit change discussion nicely segues into a discussion of what's called the Einstein Effect, which is another phenomena that inhibits creativity and innovation. The word Einstein comes from German, and it means like approach or a mindset or attitude. What it means is when faced with a challenge, the only approach we take is to use approaches, mindsets, attitudes that have worked in similar situations in the past. Well, let's illustrate it. We face a challenge. We ask, very logically, how have we resolved similar challenges? One of us says, well, like this. Then another person says, well, let's resolve this one that way. And we resolve the challenge. Isn't that great? It always works. But, what's the but? What options, creative and innovative, have we missed because of our allegiance to the past? Entrepreneurial, aspiring people must avoid being stung by Einstein. It's okay to go through that cycle, but parallel to it, try something else. I'll give you an example. This goes back many years. I and my engineering firm colleagues once had an opportunity to design from scratch how we would use a large space on one floor in our new office building. Wow, that was nice. So our original idea in Einstein Effect fashion was this. Well, let's follow the same logical layout we used before in our old office space and that we use all over our company. We'll put the engineers together, and the planners together, and the administrators together, and so on. Nothing wrong with that. One of us, I wish it would have been me, I don't think it was, said, let's not follow that initial impulse. Instead, let's mix everyone up, as shown in the lower part of this visual. The reasoning was that this arrangement, heterogeneous with respect to functions, would enhance communication relative to a traditional homogeneous arrangement. Each of us would have more opportunities to learn about the personalities, the work of others, the kinds of services we can provide. That was my experience. I was the E, engineer. On one side of me was a technician, Jerry. I learned so much about the creative and sophisticated field work that our firm could do that I didn't know before. And on the other side of me was a marketing person, David. Over a period of a couple of years, David gave me a valuable short course in marketing fundamentals. By the way, I just read something today that said some universities, of course, are intentionally doing this as they plan or reorganize their campuses. Back to the negativity bias, this idea of reacting in knee-jerk fashion when faced with an attractive proposition. Here's just some more advice on how we can help students not be sabotaged by that. Help them recognize the brain's tendency to operate like Velcro for negative experiences and to operate like Teflon for positive ones. Urge them not to react. To instead, as I just said before, start to develop a habit that's has a positive step after the cue of being faced with the opportunity. As I said before, one approach is to suggest they recall their goals and their positives, and then make a good decision. And in this whole process, always try to install positives in your brain, because the negatives get installed easy. You got to offset that. Back to vision. I noted earlier that vision is the dominant of the 6 senses. And I said, sometimes we don't seem to appreciate that. I'll give you an example. Many of our slides look like this: a statement followed by bullet points. And we think this is helpful. Well, frankly, between you and me, we know it's helpful for us because it provides notes that we can speak from. However, researchers have concluded that this is not an effective slide. And they give at least 2 reasons. One reason is that the audience members get confused by word inconsistency. They see one set of words on the slide while the speaker, paraphrasing, uses another set of words. Or the other problem with this is, in some cases, the speaker reads the slides to them, which raises the question, why do we need the speaker? A fair question is, if that's not good, what's a good slide? Well, I'll show you what research says. Research reveals that the most effective slide contains a simple, declarative kind of statement with an image. This slide, of course, is from earlier in this presentation. It's that simple. That's what research says. But that's not our natural tendency. We want to load those slides up with information. Do we want people to remember our basic message? I think so. If we do, we should at least consider the research findings. Interesting to me
Stu?
that PowerPoint's default designs make it easy to prepare ineffective slides. They are at odds with neuroscience. In the old transparency days, we often were locked into text-only slides. Adding images was difficult. We don't have to now, but some of us still do. Another vision-oriented approach that you might share with your students is to try to more often use props.
Stu, I just wanted to make sure, with 10 minutes remaining, one of the things that we want to make sure we want to invite additional questions, and I want to make certain that you get that opportunity to show some additional resources. So when our participants on the workshop want to go dig into this topic a little bit more, they have some of those resources. So I'm just being the timekeeper.
Thank you, Doug. The point here is use props more often in presentations because they build on that strong physical sense. That's all I'll say here. The next thing I wanted to talk about is the Medici Effect. I think we're all familiar with the Medici family and how they brought very diverse people together in Florence and, in effect, started the Renaissance. My point that I wanted to make here, I'll make it very quickly, is we should assemble highly diverse teams, even though that sometimes is resisted. If our goal is creative, innovative results, highly diverse teams will produce it. Ned Herman studied this, and he said if you put homogeneous teams together, you're going to have great communication, short time to decide, low creativity and innovation. But with heterogeneous teams, it's just the opposite. All right, that's a quick run through of the last couple points I was going to make. Again, my purpose, explore the idea that if we know more about brains, we can be better educators. And I shared with you some brain basics and then 7 suggestions. If you want to go into further depth on this, Elena has made available for you this paper that I presented about a year ago. Most of what I've presented today is a summary of the content of that paper. Some of you may be intrigued by what science has recently learned about that 3-pound marble between our ears. That's explained in chapter 2 of my book. My book then goes on to talk about, building on that foundation, characteristics of creative and innovative people, obstacles to creativity and innovation, what to do about it, and then presents in detail 20 whole brain methods or tools. That's the extent of what I wanted to say, Doug. Thank you for accelerating me near the end. I'd be glad to respond to any additional questions that you or others may have.
With our remaining time, what I think I will do is just solicit questions through email. You've got Elena Olson's contact information. You certainly can send things to her. She also will be sending out the links to the paper, and upon request, other links to some of the resources that you mentioned. By the way, Stu, you'll appreciate this. That student that I mentioned came up to me and asked how he could change habits. He said, I'm going into an internship and I want to have some things to do that are even outside my current work in my internship. I sent him a URL reference to your book, so hopefully he'll dig into that as well as some of the other materials and to this webinar. So thank you. You're going to have viewers not only here online, but you're going to have viewers that are going to have an opportunity to see the recording. And as questions come in, we can direct those appropriately to you. Thank you, Stu, for this presentation.
Thank you, Doug, for the opportunity, and thank you for everybody. Thank you for attending.
All right. With that, thanks, Elena, for organizing this, and we'll see you next time.